So for part 2 of the lecture this week, I really just wanted to make a quick statement about the use of light maps in creating custom 3D models. So when you go into Unity and you start testing around with the basic primitive objects like the cube, sphere, capsule, all that kind of stuff, they already have light maps that work relatively well for their purposes. But if you're making a model yourself from scratch, you're going to want to actually create light maps manually, and that process is straightforward, but it does have a few kind of gotchas, so I just wanted to describe how light mapping tends to work and what the role is that it plays in Unity lighting, but also in lighting for Unreal Engine or CryEngine or pretty much any game engine that relies on any kind of pre-baked lighting process. So I have this model here, and it's a crate model. So I'm gonna just we're not gonna worry about textures or anything like that, but I want to bring it in and I want to see how it interacts with lighting in Unity. So this crate is actually a pretty good example of how a model might have some difficulties in light mapping. So let me go ahead and drop that crate in. So I have my crate FBX. I'm going to go ahead and just drop it into the project. And then we're going to drag this crate out into the scene here. I'm going to make a few copies. And then let's go ahead and bake lighting. So we'll switch these to static. We've got our auto bake turned on. So then I'm just going to switch these crates to static, and then they will be used as part of the light mapping process. So we'll just give it a second to wrap everything up. And then we'll see what's going on here. So, okay. What you might notice looking at the lighting on this object is it's not terribly accurate to what is going on in the scene. Now it's reasonable. It's not completely awful, but what we want to look at is in Unity, you need to actually create light maps in order for an object to work effectively in a lighting condition like this. So as of more recent versions of Unity, and that's, so I'm currently on version 5.3.2, but I can't tell you the exact version where this changed, but the lighting that is baked for dynamic indirect lighting is no longer being based on the contribution of Lightmap UVs. So if we want to see whether or not this object is working for the purpose of dynamic real-time indirect lighting, what we want to do is grab our shading mode drop down here and go to global illumination and look at UV charts. And we can see that the crate actually has UV charts by default. And so I brought in another model to kind of help illustrate that, which is this archway model. So if I go ahead and bake lighting for this arch, get an idea of how that works. So if I go ahead and stick this here, change it to static, let it rebake, we'll have an idea of what the lighting setup will look like. Now this is a fairly substantial change, because Lightmap UVs have previously been a strong contributing factor in the creation of dynamic indirect global illumination. The process actually used the light maps of the objects to determine whether or not they would be utilizing indirect light scattering. So previously the only option you had was either to generate Lightmap UVs automatically or to go into the model in your art package and actually make it work. So let's go ahead and take a look at this. So once lighting has baked, you'll notice that this actually generates lightmap, basically lightmap shells automatically, and they're fairly consistent. It actually does kind of work this way. And the main thing that you want to keep an eye out for is that you can still create a custom light map to affect the outcome, but you actually, in order to do dynamic indirect light bounces, you do not have to create light maps. They do work without a light map being generated. So, but that being said, if you're going to do a not a real-time, but an actual baked light, that does require that you create light maps. So let's just take a look here. Sorry, it always takes a second when you swap out core properties like that. So, so we'll see in a second what the issue is with these objects. Okay, so you'll notice that the main environment, the cubes that have the lighting baked here, don't have any artifacts on them, but our custom objects, the arch and the box, both do. And if we want to get a visualization of what's going on here, what we want to do is in the shaded drop-down, we can go to the baked property. And basically, this gives us a clear idea of how many pixels of resolution are being used for this. So obviously, because this is a scaled object, it has more pixels on that axis, but this is kind of a decent number of pixels for each of the walls and floors. But these objects just look like a complete mess, and that's because we didn't do anything to try to give them light maps. So I'm going to go ahead and jump back to my my crate here, and I'm going to look into an Unwrapped Uv that would be a good way to set up the light maps. So first of all, if we go to so we've got an Unwrapped UVW. We open the editor and we take a look at what the UVs look like. You'll notice that basically I didn't do any kind of UVing on this model whatsoever. So this is not really a very good good texture map, but it's also a really bad light map. So I'm just going to do a quick, because we're not going to address textures right now, I'm actually just going to do a basic like flatten mapping. So I'm going to go to mapping, flatten mapping, and let's just say this is not actually what we would do, but this is what we'll treat as our albedo. And so we'll just say that that's the normal texture there. So the first thing that I want to show you is possible to do, and I'm going to do this with the arch, and then we'll make the custom UVs for the crate. So Unity gives you a process to automatically generate Lightmap UVs in the import settings for any model, and that's possible when you check the Generate Lightmap UV option, and then it gives you certain settings that you can control as far as how it actually generates those maps. So I'm going to go ahead and apply that, and then let it rebake lighting. We'll give it a second. But basically, we'll come back to that in a second and see. But the idea behind the Generate Lightmap UV is that it gives you a way of actually creating a valid process to get a light map working in Unity without many issues. And actually, Lightmap UVs look pretty similar to what we just did here with the unfold mapping in Max. So that the output of that will be somewhat acceptable, but the problem is that there's a ton of wasted space here. And light maps actually have a unique property compared to the rest of lighting in, or I'm sorry, compared to the rest of texturing, which is that they don't really get influenced by stretching as much, and they really don't get overly damaged by having things that are all attached or kind of stitched together. So in the long run, the biggest things that you have to watch out for in light maps are spacing and how many shapes that you have. So okay, so now just to take a look at what we've got here now, the arch, which is finished baking, now looks like it has correct lighting in it. And if we go to the baked path, we can see that it really, for the most part, it looks like it has a pretty good light map distribution. So it actually looks like it's a fairly even, well put together light map. And in some cases, this will work. But there are some best practices for creating light maps. And so let's jump back into Max and make our own light map for this crate. So light maps are always handled in the second mapping channel. And what that basically means is that you have to swap the channel option from 1 to 2 in 3ds Max. So I'm just going to click the up button. And this is a very confusing dialog, so I want you to be careful with how this works. Think of the word move here as copy. And then the word abandon should be thought of as switch. Like, if you use the word abandon, if you click abandon, then basically what will happen is the light maps that you generated in channel 1 will stay in channel 1, but will not be used for channel 2. If you hit move, then the light maps in channel 1 will be copied into channel 2. And this is something like, this is one of the reasons that I actually have some issues with 3ds Max. I really don't like the way that they handle things like multiple UV sets because it's a very confusing and cumbersome process. But so like the first time you create a new mapping channel, you can use move, but I try to get in the habit of basically, if I'm creating a new mapping channel, unless I want to copy what's in the original mapping channel, I don't use move, I just use abandon. And then I could go about the process myself of creating the UV maps for the light map. And so there's a couple of ways that I can go about this. The one thing that I know that I want to do is I actually want to just make some seams. And what I'm going to do is I'm going to cut off the top the bottom, and I'm actually going to cut this kind of in half. So this side, the left and the right side, will be a good chunk, and then basically, accidentally added a seam there. Hit Control Z to get rid of that. Okay, so basically we'll have two 90-degree sections, and then a top and a bottom. So then I'm going to go into Pelt Mapping. Oh, we got to select my faces first. So I'm going to grab the top, and then expand Edge Selection to Seams. And then I'm going to go to the Pelt Mapping option. And actually, what's funny about this, because it's such a square object, like, that actually worked with just bringing up the dialogue. I don't need to do a whole lot else, except that the inside faces are there. So actually, let's go ahead and we probably don't have to use the pelt, but we want to use relax. So I'm going to do like relax by polygon angles, and actually this should work fine. And now there's a little bit of distortion there, but in light maps it's actually not a problem. So let's go ahead now and grab one of the side edges, expand Edge Selection to Seams, and then I'll go to Pelt, and this time I'll hit Start Pelt, and then Relax. Oh. Relax by polygon angles. I actually might want to redo that one, because I want to do the Pelt to flatten it out, and then I want to make sure that the Relax is by polygon angles, so that it doesn't do that weird spinning thing. And then I'm going to do the same thing for the other span. Just basically get the other, oops, just get the other chunk there. So Pelt, Start Pelt, Start Relax. And then I'll do the same thing with the bottom. And I'll expand Edge Selection to Seam, Start Pelt, Start Relax. And then we should be pretty okay here. So then what we want to do is we want to make sure that we're taking the space evenly. So basically what we want to do is I'm going to go in and first select all of the clusters and go to Mapping, or sorry, Tools, Rescale Clusters, and that will allow me to get these to basically be roughly the same size as each other. And what I can do actually to make this a little more accurate is I'm going to grab the middle faces and I'm going to scale them in a little bit so that we see a little bit more space for the edges around the section. And again, this is what I mean by light maps don't care about stretching as much as they do about space, basically mapping real estate, if that makes sense. And so what we want to do is we want to set these up so that they have a decent amount of space between them, but aren't, so like they aren't contacting each other, they're not coming in contact with each other. And actually I'm going to turn on the element selection so I can grab the whole thing. Switch to the move tool with W. And okay, and so then what we want to do is we want to drop this into our UV channel 0 to 1 space. Can kind of make little adjustments here. Now, what we want to be careful of is that the space between UV spans matters, but the space between UV spans and the actual edges of the UV space does not matter. And that's because most light mapping systems actually pack the edges a bit anyway, and there's configurable options for that, but you don't want to take up space by trying to keep things away from the edges, because that's actually not going to be helpful. And so then, because, again, stretching doesn't matter as much as maximizing the light map resolution, we can basically just stretch this out. So I can switch to the freeform mode, and I can scale this out so that it takes up the majority of the space. And this will mean just that I have more pixels than I would have had if I hadn't chosen to do that. And so then I can make little tweaks, like I can grab this one and slide it slightly further to the corner. This one and slide it, drag it slightly over to the corner. Okay. And so then basically that's it. Now there's a few things that I want you to think about, which is that when you look at this, you want to have the fewest number of spans possible. So if you can keep things attached, try to do that as much as you can. Make sure you have a decent amount of space between sections, UV spans or UV shells, because that space is where you will accidentally get color bleeding between two different sections of the light map if you aren't careful about how much of a gap there is. And then the last thing is that you got to make sure that every single part of the 3D model is uniquely mapped. If you don't have every single part of it non-overlapping, anywhere that there is overlap, we'll try to write information from two different parts of the surface. So remember, while you can use tiling textures in something like your albedo, for a light map, nothing can tile because every part of the surface has unique lighting information. So now, actually, I'll probably leave the UV texture editor open. Now, just to confirm that we have our light maps set up properly, what we want to do is we want to jump back between channel 1 and 2, and we want to make sure that they're both there. And so mapping channel 2, we want to change that to channel 1, and I'm going to hit abandon. And it looks like actually we don't have the mapping that we had in our original pass. Okay, so this is an important thing to understand, and to be honest, I actually made a mistake when I started this lesson, so I want to make sure this is clear to you. There are only two ways to make sure that you're retaining information between two different map channels, and it is misleading because the Unwrapped UVW modifier only has information for one channel. So if I made these light maps, I have to move them or abandon them, and that is the only option that I have. So basically, this Unwrapped UVW is channel 2. That is what it is. So you can't have a channel 2 and a channel 1 in a single Unwrapped UVW modifier. So there are two ways around that to make sure that you have your albedo map and your light map. So one of them is, for example, if we have this Unwrapped UVW in map channel 2, I can just apply a different Unwrapped UVW, make this channel 1, and then map that differently. So I can say, grab all these, do my flatten mapping, and then that would mean that UV channel 1 would be the UVs that I have in channel 1, and then in my UV, my other Unwrapped UVW, then I would have my channel 2, which is this other unwrap. Now, I could also do some things like, so for example, I could actually rename my Unwrapped UVW, and I could call this Unwrap Lightmap, and then I could right-click on this one, Unwrap Albedo, or something like that. And that's something that I could do, but in general, I usually flatten meshes, which comes to the larger factor, which is that once you have made an unwrap and collapsed it, that is now saved permanently into that channel. So I'm going to go ahead and actually delete this albedo, and I'm going to do an unwrap lightmap channel 2, and I'm actually just going to collapse all. And then if I go to Unwrap UVW, if I open up my channel 1, so my channel 1 is actually not correct because all I saved at this point was the channel, the channel 2. But if I move to channel 2 and select abandon, then I will see that UV channel saved here because I collapsed it first. So if I switch back to channel 1 in the Unwrap UVW, I'm going to abandon. Then I can do my mapping by grabbing all these faces. I can go to mapping, flatten mapping. And again, I don't recommend using flatten mapping at all. I think flatten mapping is really bad. But this just illustrates how we can quickly get together a mapping to use for this model. So, okay, so there we go. So I've got my flatten mapping. So if I go ahead and collapse that and come back, I have my unwrap. If I open the UVs, see there's the channel 1 unwrap. And then if I switch to channel 2 and abandon, then I have my channel 2. And then I can go back to channel 1 and abandon. So the main thing that you want to do is either have 2 unwrapped UVWs, which is personally not my favorite way to do it, or make a channel 1, collapse it, then make another unwrapped UVW, make your channel 2, and then collapse it. And then that way you'll be able to retain the 2 separate channels. And then you can basically abandon between them, and this is your way of testing out how that works, because abandon in this case will actually, rather than changing the content of the previously collapsed UVs, it will just show you what the previously collapsed UVs were. So hopefully that is helpful and clarifies some issues that frequently occur with 3ds Max. Because I know it's not super intuitive to figure out how to set up mapping channels, and it's so not intuitive that I actually didn't quite plan it out correctly when I started this lesson. So I was going to cut that out of the video, but I thought that it would be necessary to actually address the fact that that is a very common mistake, so common that I made it, and I've been working in Max for a very long time. So in my case, this has been one of the things that's made me pivot from Max to 3D, from 3ds Max to Maya, because Maya, I think, has a lot more intuitive control over UVs and light mapping, and different channels and all that kind of stuff. So, but yeah, so anyway, so now I've got that light map, and I'm going to overwrite the object in the scene here, so that I have my light maps in channel 2. And then it's going to go about creating the bake. So I'm going to switch to shaded mode so we can see how this goes. Dum 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 dum. Testing, testing, testing. Now, you might ask me, why would I go about creating my own light map in Max if Unity has the ability to actually generate Lightmap UVs with the tick of a button? And the answer to that is really simple, which is that creating your own light maps gives you the ability to maximize resolution and quality. And that usually has more of an impact the lower resolution your light maps end up being. So, for example, right now what we're looking at in our scene here is the difference between basically we're looking at let me make sure that, okay, so we got the baked lighting here. So what we're looking at is a 40 texels per world unit resolution, and what actually resulted from that is that there are 3 directional light maps which are each 1024 by 1024, and that's 8 megabytes in size, and that's only for this tiny little box room, right? Now it does look pretty good, it's fairly accurate, but it's it has some disadvantages when it comes down to having a system that can scale down. So the lower our resolution gets, the more degraded it will become. So I want to illustrate that. I'm actually going to I'm going to reassemble this scene really quickly. So we're going to get rid of everything except for 2 boxes, and I'm going to stick one box that's like halfway through the lighting here. And then what I'm actually going to do is, so that we can see what happens with the 2 different features. So this is the box that we did our light mapping for. So if I go into the baked resolution, I can see what's going on there. But I'm actually going to make a copy of this. So I'm going to hit Control D to duplicate this crate. And I'm going to call this crate underscore auto map. And this one, all I'm going to do is I'm going to just generate Lightmap UVs with this tick box, and then hit apply. And then I'll drag this out into the scene, turn on static. And then what I'm going to do is I'm just going to let it bake lighting for this. I'm sorry, it takes a minute to complete, but we'll take a look at this and we'll see. What I'm going to do is I'm going to show you what the quality difference is between the crate and the auto mapped crate, and it's still taking a minute, so this is not correct yet. So what we can do is we can look at what this looks like while it's light mapped, and then we can start stair-stepping down and seeing what the effect is with each of them. So, okay, so if we look at these 2 models, we'll notice, actually this is kind of funny, because so this is the full resolution, so like the high resolution that you would normally go with, and we can still see artifacts even right now. And so, whereas the one that we made custom in Max has, basically it looks pretty smooth and even, and the light where the shadow is hitting the surface here looks fairly clean, all that kind of stuff. The shadow looks similar on this one, but first of all, you'll notice the shadow is actually slightly lower resolution than it is on this one. But then you'll also be able to see that there's this weird kind of like black outlining that's happening on the spans, and you can actually even see it right here. There's kind of this weird fade, and so if I go and I switch to the baked light map view, what you'll notice is it's actually a little bit less dense on the auto-mapped one than it is on the one where we made the custom light map. But what gets really difficult is when you start stair-stepping this down. So let's say I'm going to take this and half the resolution. Let me switch it back to shaded. And so hopefully at half the resolution it'll take a little bit less time than the full resolution, which it usually does. Okay, so at half the resolution, you'll notice that the artifacts on the auto unwrapped asset have gotten even worse, and you're seeing stuff creep in from the edges, and the shadow is really degrading very heavily, whereas our custom light mapped object still looks kind of the same as it did at the previous resolution. And so if we half that again, like this is just going to keep getting worse, basically. So now you'll notice that at even smaller a resolution, obviously this model looks fuzzier. It's not as detailed, but because of the way that we set it up, where it is maximizing the use of the UV space, it still holds up. Like, you can still say, okay, this looks like it's lit properly in this environment, and it's fairly consistent. In this one, you're already starting to see sections where, like, all of these inside faces have completely just the wrong color. And that's because they are all separate spans. So kind of like if we look at our crate in 3ds Max, the way that unwrap works for the auto unwrap is kind of the same as the way that this flatten mapping works, which is that each one of these individual spans is this really separated piece, and as the resolution gets lower and lower and lower, you're going to see more bleeding in the colors that are generated for each of the different spans. So I can go all the way down to like 5, and this model still kind of holds up, still looks consistent. This one is covered with artifacts and weird bleeding. Go even lower, down to 1. And at a 1 resolution, obviously the lighting is starting to not look very great in general. But again, this model still has a consistent, even lighting across the entire surface, whereas this one has every section of it is splotchy in a different way. So hopefully that that helps to illustrate what the difference is between creating good light maps and creating bad ones. And this is something that I strongly encourage you to pay close attention to, because this is pretty foundational to making solid game assets. So I'm going to go ahead and actually wrap this up now, because I think this is a lot of information to cover, and so for a lot of people, they've never thought about doing light mapping at all before. So hopefully this is a good illustration of the point, and can help you move forward with a better understanding of how light mapping and all that kind of stuff works. So I'm going to go ahead and wrap this up. So thanks for watching the video, and hope you got something, some new tips out of that. So, all right, thanks.